Greetings and welcome to this module on Intermediate Java. It's not clear to me exactly where all of you are with respect to your facility with the Java language, and so I like to have this lecture and module in the course just to make sure that we're all kind of not necessarily on exactly the same page, but we have kind of a minimal level of competency about some of the fundamental features of Java. And it's also kind of interesting when you compare some of these features to other programming languages, particularly the more dynamic programming languages. It shows off some of the strengths and some of the issues with the Java language. So what we're going to do in this talk is I'm going to first of all assume that you understand basic Java, just how to write syntactically correct code, and then I'm going to go over quote-unquote modern. It's not so modern anymore. These things have been around for 4 or 5 years, but the problem is that there's been so many hundreds of millions of lines of Java code written prior to this stuff that you'll often come into contact with kind of archaic use of Java when you're looking through other people's code. And so I just want to make sure that I want to raise your awareness of things that you should write differently when you're writing your own code. So we're going to look at collection classes, enumerations, generic types, and so forth in this talk. Real quick, I'm not expecting this talk to do anything more than kind of raise your awareness. You really should be reading the reference material, Java in Nutshell, and in particular Effective Java, which goes into much more detail and gives you a much more thorough understanding. But hopefully this quick talk will kind of highlight the stuff I want you to be concerned with. First thing is the collections framework. Almost all programming requires some kind of in-memory data structures. And the efficiency of your program is often going to depend upon the extent to which you can build and use in-memory data structures efficiently and correctly. And the collections framework is one way to do this. You can also use Hibernate and other facilities to kind of add persistency to an in-memory data structure, so that in fact it's actually persisting things to a backend database. And hopefully we'll get a chance to look at that a little bit in this class. So collection code, you're defining something that can hold a set of instances, and then you have high-level operations, add, remove, etc. To manipulate the collection. You also have predicates like isEmpty to check whether there are elements in the collection. So all that's pretty trivial, straightforward. The three kind of highest level abstractions that you want to be concerned about is that you have sets. Sets are data structures that don't allow duplicates. Lists are ordered sets of ordered collections. They can have duplicates in lists. And then maps are key value pairs. Okay, so that's the top level fundamental abstractions. Whenever you're thinking about an in-memory data structure, you want to think, essentially, do I want a set, list, or map? Those are usually, the three choices you're going to have. But you don't actually create, in general, a concrete instance called a set. You're going to use another concrete instance of one of those high-level classes, which provide either additional operations or implemented in such a way as to produce efficiency with respect to space or time. Okay, so and Java has a bunch of these things, and then there's other libraries out there you can download that extend them in other ways. You can see if you look through this list, there's facilities for concurrency, which is real important in web application development, sorting, and so forth. Okay, now when you're looking at old Java code, you may come across the use of the vector class or the hash table class. If I see those classes enter any of your code, I'll be highly distressed. Don't give me heart palpitations if you find this code in any classes that you're using. You want to, as I said before, you always want to reference where you got code from if it's not yours. But if you're using some little snippet of code that you got someplace else and it contains these classes, then you got to fix it. You go from vector to array list or whatever, and then add an annotation, code adapted from and wherever you got it from. Okay, so it's very important to choose the right collection class because that's a form of documentation. By specifying that you're using a tree map, you're stating there is a need to keep this in a certain kind of sorted order. So you want to be careful about the way you choose the classes that you use because that's telling, the future reader something about your system. So for example, let's say we wanted to design a class called compact disk that should hold instances of compact disks and those instances of a compact disk can be held in a collection, and that collection supports retrieval of these instances by their title, and you can sort them and so forth. And so the thing I want you to think about is what collection class would you use for this, and in particular, what methods of the higher level object class should be overridden in order to make this function effectively. And this is the key thing about collections in Java, is that when you implement a class which is holding a collection of instances, okay, which represents a collection of instances, you need to override, when you're implementing a class which will be held in a collection, you need to override that class's equals and hash code method at a minimum, and generally the compare to method as well. And this enables that class to be kind of collection safe, to operate correctly within, if you have a tree map holding instances of a compact disk object, you have to implement the equals and hash code and compare to method in that compact disk element so that it can function correctly in the tree map collection. Okay, so you override equals in general to use logical equality, not instance equality, so it's not just looking at the address of that object in memory. You override hash code so that if you have two instances of the class which are logically equal, they're going to produce the same hash code value. And then you override the compare to method to support ordering amongst elements. Okay, and so you can look at Java in a nutshell. They have some information on this, and Effective Java in particular has a very good discussion of the motivation behind this, the way you do it, correct ways, incorrect ways, efficient ways, inefficient ways, and so forth. It's very, very good discussion of this, and you'll learn a lot of interesting stuff from it. Let's move on to enumerated types, another feature of Java that you should be aware of when you need to represent a small number of values, and you don't want to be giving each of them a different integer or whatever. So you can declare this enumerated type, and it looks like this. And then you can write code that asks if an instance of this is equal to one of these small numbers. And then do various things. Okay, so here's a little bit of code that just shows the use of an enumerated type. And if you read about enumerated types, they're pretty cool. You can do a lot of stuff with them. This is just the most trivial example of an enumerated type, but it's actually a pretty cool feature. Okay, generic types. This is one of the, along with collections, this is one of the key things that you should always be doing writing your code in Java. In fact, Eclipse will issue a warning if you're not using a generic type. So you kind of have to work a little bit at this point to not use generic types. This is some code that would signal warnings in Eclipse. It concatenates the elements of a list of strings together and returns the resulting string. So this is the way we used to have to do it in the bad old days of Java. We'd accept a list, and then we'd create this string buffer, and then we'd iterate through the elements of the list, appending the elements, and then return the resulting string. Okay, so the problematic part of this is the fact that our parameter to this method says I just need a list, even though in the body of this method we are casting each element of the list to string. So there's a requirement, and then we invoke a string method called append on that element. Okay, so the method actually requires a list of strings and will throw a runtime error if it doesn't get a list of strings, but there's no declaration of that specifically in the types of the function. Now this is, if you're using Python or many other dynamic languages, this is just par for the course. Okay, you have these high level types like list, which can represent lists of strings, lists of integers, lists of strings and integers, and then you're just expected to kind of deal, right? Write code that works correctly and make sure no weirdness gets in there. That in many cases, it can result in I guess fast coding, particularly when you're writing little scripts to do small little things, and you're very confident of what the environment is in which the script is going to be called, and the costs of runtime errors are low. If your script fails because you did something wrong, you just re-invoke the script with something else, and everything's okay. However, in certain other circumstances and large programs, you really don't want to. You like more help from the programming environment about the kinds of objects that are being manipulated and earlier kinds of warnings that things are not structurally correct. So, what we can do in Java is we can declare not only the top level type that it's a list, but we can also declare what the elements of that list have to be. And that forms a contract which can be enforced at compile time, not noticed at runtime when you try to do a cast and things fail. Okay, so modern Java looks like this. You're going to declare a list of strings in the parameter list, and then we have this for each element, so we don't do any kind of casting inside, and we got this convenient iteration construct for iterating through. You can say for string element in list, that little colon in the middle there means you kind of pronounce that as in. So for element in list, do append of the element to this buffer that we've created. Okay, so lots of errors disappear magically when you can declare the complete type of an object in this way. Okay, there's some limitations. You can pass null, unfortunately, or fortunately, I guess, depending on bug or feature kind of thing. And secondly, you've got to remember that when you're dealing with the outside world, that's where weird types can kind of creep into your program and cause havoc. So whenever you're dealing with external systems, be they humans or other programs, you should immediately check your input types upon entry to make sure that they're conformant to whatever you need them to be, and not let them get any farther. Okay. There's also the ability to create generic classes. Okay, so for example, let's say we wanted to create a class that represents a stack of numbers, where we could have various different types of numbers. Here's an example of a class called NumStack. It's not really an example of the complete class, but just kind of the skeleton. And then you see an invocation of, or a definition of a NumStack instance below, where we're going to create a NumStack that represents a stack of floats. Okay, and so this is another, when you want to create a class that can be parameterized with different types, Java provides this particular facility. It's a little more complicated to use, but can definitely create higher quality systems when you need that capability. Okay, now in Java 7, there's this nice kind of partial form of type inference that's now available. It cleans up your code a fair amount. You can look at this top example, list of string mylist we're declaring. Generally, before Java 7, we'd have to say new list of strings. So you can see this list of strings appears on both sides, the declaration and the instantiation of this mylist variable. Okay, and a lot of people say, why do I have to say list of string on both sides? I mean, that's just completely redundant. Can't this silly, compiler figure out that if I'm declaring this thing to be a list of strings, then on the other side it's a list of strings as well? Finally, with Java 7, the compiler can indeed do that. So now you can see this mylist on the left-hand side is declared as a list of strings, but on the right-hand side of the equal sign, we have just this diamond, the left angle bracket, right angle bracket, and we don't have to say list of string. Okay, so list of string is kind of a less complicated declaration, but you can imagine a list of strings, inside a map that does this and that, and you can save yourself a lot of redundant typing and by using this type inference construct. Autoboxing is a nice feature in modern Java. The idea here is that you can go back and forth between integers and their primitive, between classes and their corresponding primitive types without having to explicitly do casting or conversion. So here we have an example of a class where in the parameter line we declare a list of integers with capital I, and then inside we manipulate those components of that list as ints, as the primitive type, because we can use arithmetic on it and so forth. And everything just kind of works the way you'd expect it to. Again, it's no big deal. But when you can't use primitive types in the type specification for collection classes, so you have to use the big I integer, and you use the small I int when you're doing arithmetic operations. Annotations. This is a cool feature. Again, you will be using it in this class. They don't change. They're kind of compiled out, but they provide information to the compiler that enable you to do nice things. Here are 3 examples. The override annotation is extremely important. Eclipse is going to want to see you use this correctly because it helps guarantee that when you think you're overriding equals or hash code, you actually are. So for example, hash code, you could spell it with a lowercase h and a lowercase c, or a lowercase h and an uppercase c, and there's the capitalization of that method is significant, and oftentimes you might forget to capitalize the c, and so by providing that @override annotation, the compiler will check if you intended to override a superclass method. It will make sure that that's actually happening, and that can really, 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 I tell you from personal experience, that when you mistype, or get incorrect capitalization on a method, and you think you're overriding and you don't, you get bugs that are very, very hard to diagnose. But if you just include this @override annotation, all that problem goes away. When you're writing test cases, the @test annotation is useful. Guarded by is used by the PMD tool. So there's a whole bunch of these, and I'm just showing you 3. Okay, so that's my whirlwind overview. What you really should be doing is reading Java in a nutshell and effective Java, being very careful when you look at old Java code to make sure that you're not learning bad habits, and we'll be getting ample opportunity to be practicing this as we go forward in the course. All right, thanks.